Okay, so let's talk about permutation versus combination. So permutation, difference in order is important. So if you have a set of x, y, and z, the set of x, y, and z, and the set of y, z, and x count as two different sets. Even though they're the same, they count differently for permutation. For combination, they would count as the same because their contents are identical. And that's the difference between permutation and combination. And we'll talk about a couple of different examples on how to tell the difference. All right, so for permutation, let's try a real simple example. Let's say you have 4 books. And you want to put those 4 books on a shelf. It doesn't matter what order they go in, so you can put them however you wish. So if you have 4 slots on a bookshelf, you have a choice of which 4 books you're going to put first. You've used 1, so you have 3 remaining. Now you've used 2, so you have 2 remaining. And you have 1 book left in your hand. All right, this is what's called the fundamental counting principle. And you can actually solve quite a few permutation problems with this. This function, 4 times 3 times 2 times 1, is called factorial. All right, and it can be represented as 4 with an exclamation point. And it just means you start at 4 and you multiply your way down to 1. So I know that 4 factorial, 4 times 3 times 2 times 1, is going to work out to 24 possible arrangements. And that's basically how permutation works. You count down how many options you have and multiply all those options together. Now, it gets a little bit more complicated if you have 9 books, right, and you're only choosing 4 books to put on the shelf. Okay. So I'm not putting all 9, I'm only putting 4. And here's where our standard form for permutations is going to come in. Standard form for permutation is NPR, where N is your total number of choices, and R is what you're taking. Okay, so for example, I have a total number of 9 books. Now I'm taking them 4 at a time. And this form is n factorial over n minus r factorial. So we're just going to plug that in. 9 factorial over 9 minus 4 factorial, which is going to work out to 9 factorial over 5 factorial. Okay. Now, 9 times 8 times 7 times 6 and so on is going to give you a ridiculously huge number. And that is intimidating to a lot of students. So make sure that you point out that even if it's a factorial, anything divided by itself is still 1. So we can expand out to a point, 7 times 6 times 5, and I'm going to stop there. So I'm going to leave my factorial at 5. Because even though they're factorials, they still cancel out. Tell me that this is going to work out to be my total number of choices. And now a lot of these books are going to be the same. So I may end up with the same 4 books on the shelf repeatedly in different orders. All right, that's okay. For permutation, it doesn't matter. So long as they're in a different order, it still counts as a different permutation. And that is true even if some of them repeat. Let's say of these 9 books, 2 are history and 2 are science. Okay, so in this subset, I have another subset. All right, in that case, this is called repetition. We just add the factorial for every repeat into the denominator. So with repetition, okay, it's still n factorial over n minus r factorial, but we're going to add a subset factorial for every repeat we've got. Okay, so for example, if you're doing permutations of a word, every time a letter repeats, you would get an extra factorial. Okay? And it's just however many times it repeats. So in this case, it's still 9 factorial, and this is 9 minus 4 factorial. And I have 2 repeats with 2 choices each. So that's 2 factorial, 2 factorial. And we're just going to expand and cancel. So 9, 8, 7, 6, and 5. So those cancel out right away. 2 and 1, 2 and 1. So 2 goes into 8 4 times, 2 goes into 6 3 times, giving me 9, 4, 7, and 3. So a set with a repeat in it will give you a dramatically smaller number of possible permutations. In this case, even though you only had 2 repeats of 2, that still cuts your number of choices by 1/4. Okay, combinations. So long as a set contains the same terms, it counts as a different set, or counts as the same set, I should say. So, for example, say you're trying to make a poker hand. All right, you need a 5-card hand, 4 cards from one suit, and 1 from a different suit. This is definitely going to be a combination problem, because a hand of 9, 10, Jack, and Queen, and a hand of Jack, 9, 10, and Queen. In poker, these are the same hand. The fact that they're out of order doesn't matter. The contents are the same. These are the same hand. So this is going to be a combination hand problem. Okay. And for combination and CR, okay, it's still your total number of choices, but in the denominator, it's going to be what you're taking, factorial, and your total minus a take, factorial. So these two should always add up to your numerator. So we have 2 takes. I'm taking 4 at a time, I'm taking 1 at a time. So I have 2 combinations. So for my first combination, there are 13 cards in a suit. So that's going to be 13 factorial. And I'm taking them 4 at a time. So that's 4 factorial and 13 minus 4 factorial. Okay, move that up a little bit. So 13 factorial over 4 factorial and 9 factorial. Notice that they do add up to 13. For my second combination, I'm taking them 1 at a time. So that's still 13 factorial, and it's going to be 1 factorial and 12 factorial. And as a last step, we would multiply our total combinations to see how many total possible combinations we have. So just like for permutations, we're going to reduce. So it's 12, 11, 10, and 9 factorial. 4, 3, 2, 1, and 9 factorial. So our 9 still cancel out. 2 goes into 10 5 times. 4 goes into 12 3 times. And 3 goes into 3, leaving us with 13 times 11 times 5. And for this one, this is almost going to cancel out completely because 12 factorial and 12 factorial match, so those cancel out. So times 13. It's going to give us a pretty large number of choices. Okay. So once you figure out which one you're doing, combination and permutation, the math really is very simple. It just comes down to plugging it into the formula and multiplying it out. The trick is knowing by looking at it which one's permutation and which one's combination. All right. And it does come with some practice, but the key is to ask yourself, if I rearrange the terms, am I going to count it as a different set? Because if I can rearrange the terms and it counts as a different set, then it's permutation. So let's say you're making a display of guitars in a store. Okay? So I have a red, a blue, an orange, and a white guitar. And I want to arrange the display. How many different ways can I arrange it? Well, that's a permutation problem, because the different ways that you arrange them is going to give you a different combination of colors. And it's going to be visibly different. Each possible order will give you a different result. That is definitely a permutation problem. Okay? If I'm putting, say, fruit in a bowl, I have 5 apples. How many different ways can I arrange them in the bowl? That's a combination problem, because it doesn't actually matter which one's which. Right? So every possible combination is going to work out to be the same. So that would still only be one set. So that's how you tell the difference. And it does come with some practice. For those of you working in the new geometry, it comes at you in credit 1. I know it's tough. The examples aren't the clearest. Right? But if you do the extra problems in the book, make sure you do it before your students do. If you do the extra problems in the book, you can figure out and get a pretty good handle on recognizing permutations and combinations when you look at them. It doesn't seem like it's that important, but in the 3rd section, they're talking about probability, and probability depends heavily on whether or not it's permutation or combination. I'm going to talk about that in another video. But make sure that you do that extra practice. If you only do one piece of extra practice in geometry, make sure it is this section. Everything else you can figure out on the fly. But permutation and combination, definitely you're going to want to put some effort into that.